In this video, I am going to explain interface L298N DC motor driver module with Ardunio. This is the driver L298N motor driver module pinout diagram. Here two outputs, output 1, output 2. This is the two outputs. Two DC motors are connected to these two outputs. Next one, these are the some pins. VCC is range from based on that DC motor, 5 volts DC motor, 10 volts DC motor, like that. Have to apply VCC, and here ground. This is the ground. This is 5 volts. These three pins are especially meant for supply to the driver. Here 1, 2, 3, 4. 1, 2. Here enable A pin. Here enable A pin, and input pins. Input pin IN1, IN2. These two are for motor 1. Motor 1. These three pins are allotted for motor 1, and IN3, IN4, and enable B. These three pins are allocated for motor B, motor 2. These motor 1, motor 2, DC motor 1, DC motor 2. Then IN1, IN2, IN1 and IN2 pins are particularly meant for pinning of these motors. IN1 and IN2, these two are input pins for motor 1 spinning. IN3 and IN4 are input pins for motor 2 spin. Enable A and enable B. These two are the speed control pins. Enable A for speed control of the motor 1. Enable B for speed control of motor 2. Instead of motor 1 and motor 2, we use motor A and motor B. These are the pins description of this driver, L298N motor driver. This is the spinning direction of the motor, can be controlled by IN1, IN2, IN3 and IN4. Speed control of the motor can be controlled by using enable A pin and enable B pin. This is the interfacing of this DC motor and DC driver with Ardunio. These are the 6 pins. This one is this one is enable A. Enable A. This one is IN1, IN2, IN3, IN4, and finally green enable B. Enable B. Here jumpers are removed and connector. These are the 6 pins, 1, 2, 3, 4, 5, 6. The order is like that. These two pins are particularly meant for motor A connectivity. These two are particularly meant for motor B connectivity. Here 12 volts DC adapter, 12 volts adapter. Generally we use in our lab 0 to 30 volts a regulated power supply. Regulated power supply. Here we use 0 to 30 volts regulated power supply. By using that one, set 12 volts. Here need not use this one. Need not use this. Here one more important connection is negative of that adapter is connected to ground. Negative of that adapter is connected to Ardunio board ground. In this one, here we use for enable A. For enable A, 9th pin is allocated. That is a pulse width modulated pin. That is the 9th pin. Pulse width modulated pin means the value is like from 0 to 254. 0 to 254. This one is analog representation. IN1 is connected to 8. This one is digital pin. This one is digital pin. IN2 is connected to 7. This is also digital pin. Here IN1, IN2, IN3 is connected to 5. This is also digital pin. IN4 is connected to 4. Digital pin. Digital pin 4 is also digital pin. For IN3, ENB, enable B is connected to 3 pulse width modulated pin. That is analog representation. For enable A and enable B, for enable A this one and enable B this one, we use 9th pulse width modulated pin and 3rd pulse width modulated pin. The value by using analog, right? You have to represent this one. This is the description. This is the sketch. Already explained. Integer enable A pin is 9. Here the pins are enable A, enable B, input IN1, IN2, IN3, IN4. For enable A, this is the pulse width modulated pin. These are this one. This is also pulse width modulated pin. This is the 9th representation here. 3rd representation is here. All these are digital pins. Digital pins. In the void setup, declaration part, all these are output pins. Enable A is the output. Enable B pin is output. IN1, IN2, IN3, IN4 are outputs. Void setup declaration is completed. In the void loop, for spinning rotation, digital right, IN1 pin is high, IN2 pin is low for motor A. For motor B, IN3 pin high, IN4 pin is low for motor B. This is for motor A. This is for motor B. This is a spinning purpose. For speed control purpose, we use values. Values are range from 0 to 255. For integer speed is equal to 0. For integer speed is equal to 0. Speed less than or equal to 255. Speed plus plus. Here we use for enable A and enable B, we use analog right pin. This is analog right. Enable A pin. This value we use analog right. For digital pins we use digital right. For enable pin we use analog write. Enable A pin speed, enable pin, enable B pin speed. Delay is 10 for one direction. In another direction, we use low high. The speed is from maximum to minimum. This is the enable A pin speed, enable B pin speed. Here we use analog rate. Delay 10 milliseconds. Delay 100 milliseconds. Delay 1000 milliseconds. With this, the spinning of motor clockwise direction. With this, the topic is completed. If you like this video, please subscribe the channel for further updates. Thank you. In this video, I am going to demonstrate on DC motor with the L298N motor driver. This is the code. Belongs to two motors. These are the two DC motors. This one is L298N motor driver. This one is Ardunio board. Have to made connections between these three components. These three two motors and motor driver and Ardunio. This is the DC supply. 12 volts or 10 volts DC supply is applied to motor driver. First of all, on this one, these two motors are rotated clockwise direction and anti-clockwise direction. Clockwise direction and anti-clock direction. This is the demonstration related to two DC motors with driver and Ardunio board.